talking about a lot of stuff. We've got a lot of things to cover today, and some of this gets very technical, especially in the second part of the talk, when we're talking about software-defined networks and network function virtualization. We'll take a short break and we'll do questions between these two so that everybody doesn't get too brain fried. IoT security, it's been in the news a lot lately. And one of the things that you can do as a takeaway here, I hate to be the bearer of bad news, but in this case I'm going to be, because the news right now is really actually not very good. And we're going to talk some about that. I'm going to refer to this slide a lot, and I want to walk you through this. We're going to actually spend a couple of minutes on this because I want you to understand some of what's going on, and it really is a little bit frightening, okay? This is all just in the last few months. This is a very timely topic. When Larry called me to ask about this, I thought, oh, this is good. There's been some recent stuff. And then more stuff happened, and more stuff happened, and more stuff happened. And I kept adding things to this talk, and I finally said, you know, I can just talk about what's happened in the last couple of months. Right here, on only September 13th, Bruce Schneier, who some of you people may know, he's kind of an internet security guru, has been doing this stuff forever on the internet, wrote a really interesting blog post talking about how someone is learning how to take down the internet with a series of probing attacks. What they were doing is they were launching small attacks, scaling them up, forcing the network operators, carriers, data centers, whoever it was, to respond so that they would show what their security measure was. And then they'd back off. And then they'd wait a little bit, and then do it again somewhere else. Or they'd push a little harder and see, okay, what's the second level security measure? Okay? This was a trend that was starting to show up in logs across data centers and service providers and hosting providers all over the world back as early as last summer. Only a week later, after he wrote this, there was a massive denial of service attack on Brian Krebs' site, who runs a site called Krebs on Security. Only a month later, we had this one that you may have heard of. I'll talk about this one in a little bit more detail. That was the DDoS, which is distributed denial of service. The idea of a DDoS attack is that you somehow get a whole bunch of machines out on the internet to all generate traffic to the point of attack. There are mechanisms that will allow one machine to generate a lot of traffic, but the problem there is you've got bandwidth challenges in getting that there, and also it means that you've got one thing to shut down, which makes it much, much easier for somebody to defend against. A distributed denial of service attack, and we'll talk about why some of these are so scary, is really different because it comes from a whole bunch of different places at once. There's no good defense against it. A month after that, and this one's really scary, this one failed, but could have been much, much worse. Deutsche Telekom customers were knocked off the internet. 5% of their customers, 1 million of them, were knocked off the internet by the Mirai botnet, which is the same botnet that was run behind this attack, and we'll talk a little bit about Mirai later as well. Okay? The only reason this didn't work is because they made a mistake in their code, and instead of taking over the routers, they wound up locking them up. Deutsche Telekom was able to get a firmware patch from the vendor of their modems, put it up there, and they had everybody power cycle their modems. The next time they power cycled them, they fixed the problem. Okay? But this was a very near deal. By the way, if they'd been able to do this, they could have gotten something 20 times larger than that. And by the way, this right here is 10 times larger than this one. And we'll talk about what this one did. This one actually brought portions of the internet to a complete standstill for almost an entire day. A few days beyond that, this one's actually really interesting. Checkpoint Technologies discovered Gooligan, which is a new vulnerability that has rooted 1 million Android devices already and is adding 13,000 every day. Okay? Not good news. The Switcher Trojan, Android phones attack router DNS, and just a few days ago, just a couple of weeks ago, finally we're seeing some government action. I think this is going to fail, but it's interesting because it is at least setting a standard that we're going to have to change some things. FTC has actually sued D-Link for selling insecure routers and webcams. We've known security was a huge challenge, but we've really done nothing about it for a very, very long time. This isn't an ignore it and maybe it'll go away kind of situation, but it actually worked for a while until the device count got big enough to be attractive to the bad guy. Remember a few years ago, you probably heard some people say, I use a Macintosh because it doesn't have any viruses and nobody can do anything bad. There's no malware on Macs. Why was that? It was primarily because nobody used them. There weren't enough Mac users to be interesting as a population to attack. And so the people who wrote viruses didn't bother attacking Macs. As soon as the Mac got popular, that changed, okay? The Mac is every bit as susceptible to viruses and compromise now as a Windows PC is. The Dyn attack was huge, okay? This was the largest distributed denial of service attack that the internet has ever seen. It was over 100,000, well, at least 100,000 devices. It also, the way this attack worked, it generated each attack request to DNS was structured in such a way that it would generate subsequent requests to DNS. So in a way, it was a self-amplifying attack. It was actually kind of clever. It started in 2 waves. The first wave was only 40 to 50 times the normal traffic, okay? Surely your networks can handle that, right? Actually, theirs did. They mostly repelled this. This slowed things down some, but they did reasonably well at repelling that. 6 hours later, all of these guys came down on them like a ton of bricks. And they wound up just getting hammered. Peak attack traffic was 1.2 terabits a second. Okay, think about that for a second. That is an enormous number, folks. Okay, almost nobody has, you know, the bandwidth that was consuming is astronomical. Okay, here is a list of the people who were influenced by that attack. Okay, some names you may have seen here. Okay, that's not a complete list, by the way. Okay, this is just some of the big names. All right, Crunchbase, Wired, Zillow, Airbnb, Amazon, Shopify, Quora, Reddit, Indiegogo. You can read them. It's all over the place. The internet was designed to survive a nuclear war, not to be in one. Okay, one of the fundamental assumptions of the internet really is that only the good guys are connected to it. Okay, it did originate as a defense network. It is very tolerant of damage. It will route around damage. It will reconfigure. It's really good at that, okay? But they never really worried about having to defend from enemies within. And that's really where we are today, and one of the important points that I'll make here in a second. Device, that's supposed to be manufacturers. I obviously dropped an M there. Are responsible for their own security, right? As we said, the internet model assumes generally that hosts are required and responsible for their own security. It's good guys, right? They're going to do that. That was originally implemented in the RFCs as host requirements document. There isn't a security requirement, and I'll talk a little bit about why that's probably not a good idea, because it would be a monoculture again, and monocultures are actually really dangerous because as soon as you have a monoculture, you have a lot of vulnerabilities. All somebody has to do is come up with some way to break that, and you're done all over. But the problem is also that most IoT devices are embedded. Some of them are actually deeply embedded. The smaller they are and the cheaper they are, the more deeply embedded they are, which means the more limited are the resources that they have to deal with any kind of attack or intrusion. The biggest concern usually is these two, okay? Memory and code size. A few years ago, I was working on an embedded device that we were ecstatic because this was a deeply embedded device for monitoring in utility scale solar power plants. And we had 96K of RAM, not meg, K, all right? We were ecstatic. We had enough memory for packet buffers. We could actually buffer traffic, okay? What was our code size? 32K, all right? That's still, there are still a ton of embedded devices out there that only have 32K of RAM, okay? This is changing as we move to the ARM generation. We're starting to see ARM core processors reduce in price enough. They're starting to show up in embedded devices, so we're starting to have more capabilities, which is a good thing and a bad thing. But the big thing here is, if you've got that little code, having code in there that allows you to update it is sometimes a very difficult thing to do. And when you've got a device that only sells for several dollars or a few dozen dollars, then adding another dollar to put enough memory in it that you can actually update safely, because to update safely you have to have one copy of what you're running, and another copy of what you're running. And you download this one and you do checksums on it and you make sure it's okay. And then you say, yay, verily, you're good to go. We're going to swap you guys and start running the new one. Okay? But that means you have to have twice as much memory for that, twice as much storage for that somewhere. That adds cost. In a consumer device, that's a decision that often does not make the cut. And so that's the reason why a lot of IoT devices are actually not even upgradable. It may not be possible to upgrade the firmware in a lot of IoT devices. It's usually not a priority for the folks that make these. I've been involved in this. I can definitely tell you, having been through the arguments, I've always insisted on the ones that I've done that we had some way to change the code securely. But often what you do is you ship first and add security later if your customers whine about it, okay? Or if something bad happens. But the first priority is get it to ship, okay? It's rare for security and penetration testing, to even be in the budget or dev plan of most embedded IoT devices. That's unfortunate, but true. It is rarely revisited after first customer ship, and that winds up creating a situation where we've got billions of insecure zombie devices that are not, will not be, and can never be made secure. Okay? That's an important point to take home here. Everything's vulnerable, okay? Every kind of IoT device is potentially a vulnerability here. So anything that talks to the internet at all, really. Here's a case study of a really bad one that happened, again, just a few months ago, a vulnerability in Netgear routers. A lot of their new routers. Now, this might be a big deal because Netgear is 23% of all wireless router shipments, all right? The top 3 vendors account for 75% of what's out there. And by the way, ASUS has also had a really big, hairy vulnerability recently. So you've got half the routers that have been sold in the past year that are probably pretty heinously vulnerable. How bad is the Netgear deal? They're fixed this on some of these now. But this vulnerability was about as bad as it gets. It allowed remote, unauthenticated attackers to execute arbitrary commands with root privileges on the router by getting any user on the network to click a link. That's all it took. That's as bad as it gets. Now, that means they can take over not only the router, but anything connected to the router, because now they can do other things once they're in there and have control of the router. It really is this easy. You just basically build a link that has the router's address /CGI bin, semicolon, and then whatever command you want it to run. Okay? These routers run Linux, so that command is something that's fairly powerful and easy to exploit. You can actually also use that to kill it. You can run this command, and this is what Netgear recommended that they do before you have a patch, other than unplug it. By the way, CERT, the Computer Emergency Response Team, said their official response to this was, well, everybody should unplug these routers. Yeah, right. All right. That didn't happen. It's not going to happen. Okay. This uses the bug itself to actually run a kill all on HTTPD, so it'll kill the web server. But this is only secure until the next time it gets rebooted, at which point it'll come up and be vulnerable again. How long would it take you to know if your router was compromised? Okay? I'm pretty aware of this stuff. My router was owned by somebody for 2 weeks before I figured it out. It's not obvious. And people don't look at IoT devices the same way they look at their PC or even their phone. Most of these things don't have any kind of antivirus or security software on them. How would you even know? How would you know about your thermostat, your smart light bulbs, blah, blah, blah? You wouldn't, okay? The FTC suit against ASUS, TRENDNET, and D-Link. D-Link's the big one here. They are leaning toward this. They're not going to, I don't think these suits will ever get to court, but they are trying to really put some pressure on people to have this OWASP support. This is a compliant open web application security project. They're saying this is kind of the minimum that you need to be compliant to avoid getting in trouble. IoT is different than a lot of other security. When we start talking about security for things like PCs, and especially other endpoints, right, end nodes, because PCs are clients. IoT devices are inherently almost always servers. They almost always have a web server built into them. Because of that, they're uniquely vulnerable in some ways. They're usually a web server or at least an API server. How do you configure and authenticate these kinds of things in a loose, undefined environment where you have administrators who know nothing? Okay, and we're talking a lot about consumer devices, although you have the same problem in a lot of commercial environments. How do you do that? That's a real problem. This whole idea of identity and authentication is actually huge. How many compromised devices does it take to compromise your network? One. All right? This is why I'm saying this isn't a friendly talk. There's some nasty stuff going on. Our conventional security models, we started out a lot of times with this one. We had the hard, crunchy shell and the soft, chewy core, and we had firewalls here, and we relied on those firewalls to protect us. We were really thinking that that would do it. Then somebody said, maybe it's not a good idea to have only one thing protecting us, okay? Maybe instead of the wall at the border, we maybe need some police inside the country too. And so I said, well, we'll do this onion layers thing. The problem is, with a lot of these IoT devices, they're starting out from here. So you don't really have a lot of opportunity to defend yourself. Here's some relevant quotes. Scott McNealy famously said in '99, you have zero privacy anyway, get over it. Okay, I'm saying today, you may well have zero security anyway, get over it. Get over it in the sense that I'm not really encouraging you to not worry about it, but to recognize that every device attached to your network anywhere is a potential threat. Okay, even the ones inside it, even the ones that you trust the most, you really shouldn't trust them. You really can't trust anybody anymore is what I'm saying. With IoT, the barbarians aren't at the gate, they're already inside it. A couple of other ones. Immigration without assimilation is invasion. That's what Bobby Jindal said. And firewalls won't save you anymore. Remember that one. It definitely is true. This one's amusing, but it's not. You can look at it later. It's not relevant. We need to move on. The only possible way out is to start using kind of adaptive traffic and behavioral analysis methods to look at what the devices on your network are doing. And when you see them starting to do bad things or questionable things, or when you know that you have a device that is potentially vulnerable on your network, and you've got something in your network that's smart enough to know that there's a potential vulnerability there because it's found that device, then we'll start to have databases of vulnerabilities. We can look for those things when we start to see, look, I know that light controller is vulnerable. And when I see somebody execute what I recognize as an attack to take it over, I'm going to interfere with that and stop it from happening. All right? That's the kind of behavioral analysis you have to have, but that means you need smarter devices inside your network that know a whole lot more about how to apply security policy than what we have today. There are starting to occur. This was I think this is probably the most interesting thing that came out of CES this year. Norton introduced this new Norton Core router. It's really cool. It's a really great idea. It's $200, which is not a lot of money for something like this. It monitors the traffic on your network and isolates nodes that have been compromised. It talks to an internet database of all this stuff. And the only reason it's going to fail miserably is because they expect the consumers to pay $120 a year for the subscription for that information that it's going to use, that database it's going to use to try to determine what's good and what's bad. That's not a great deal. I don't think a lot of people are going to go for it. We are starting to see there are other bright spots. McAfee has introduced similar software that will run on ARRIS cable modems. It also has the subscription flaw. We're going to have to get over this because most people, especially most individuals, especially if they're cheap like I am, okay, they're not going to pay a subscription fee for security. And you guys, a lot of you, are in the situation of running networks that are going to be vulnerable to these things. So putting this in the network is an important thing. We'll talk some about that in the next talk. Sweet dreams. That's it for IoT. We're going to take a short break and do some questions, and then we'll move on to software-defined networks and NFV.
What do I care if my refrigerator is infected or somebody has, it's like, I guess my point is
You may not.
But, so I guess my point is, in terms of, it sounds like it's going to cost money to fix this. And so it's like, where is that motivation to fix it going to come from if, like my sprinklers are infected with
That's an excellent question, and that's exactly why I said that I don't think it will be successful to try to push this cost off on the consumer. They don't care. Do you care if your refrigerator's infected? No. Okay, you've got a smart refrigerator, you don't care. Your sprinkler system, your thermostat, you don't really care. If it continues to work and perform its function, you don't care. But if it's part of one of these distributed botnets that's launching an attack on other resources on the internet or other parts of the network, somebody cares, okay? And what I'm saying is we're all in this together. We're all going to have to, shoulder some of the burden. But I think really this is primarily going to fall on, the carriers and service providers. A lot of the folks who are represented by people in this room. They're the guys with the most to lose. They're also the guys who are really largely in the only position that you can do much about it. Okay. Well, the next talk, as we go through the next talk, keep in mind that security quite likely is one of, if not the killer app for network function virtualization.
I just have a question. If you could explain how and why this works. At AT&T, they're moving for the employees to a platform where you can't even use a thumb drive to plug into your computer. And where my daughter works in the Bay Area, they're not allowed to have thumb drives at all. And how does that infect and what does it do? I mean,
it's a huge vulnerability. It's a different thing because it's not network. Okay, it's a compromise through the hardware itself. But any file that you can bring onto the system, I actually think that's foolish, because you can get to files other ways. Okay, this is another one of those false sense of security things. A lot of people worry about it. A lot of older computers, especially, if you were running older operating systems, you could put that thumb drive in and they would automatically execute files if they were configured a certain way on the thumb drive. That's been taken out of most modern operating systems. So unless you're running XP or a really old unpatched version of Windows 7 even, that's not likely to be an issue for you. You can't do that anymore. It doesn't happen automatically anymore in Windows 10. It doesn't happen automatically anymore in Mac OS. So a lot of those things have gone away, and some of those are kind of slamming the door after the horse is gone and out over the horizon. That said, any file is potentially vulnerable, particularly if it's something that you can run, okay? If it's an executable or anything that causes executable-like behavior. Zip files, for instance, do that. It's one of the reasons why a lot of you have probably noticed Google will not allow you to mail zip files around, okay? Unless you change the extension, which is enough to fool their really brilliant detection software. And if you change it from .zip to .zit, it will fly right through. Somebody can change the T back to a P, and all worked, okay? But yeah, that's the reason. Yes?
What's a good way to check if your router or your IoT device has been infected?
There isn't a good way right now, okay? How did I do it?
How'd you find out?
Well, I'm a network protocol guy, and I was playing some stuff on my network, and I noticed some weird behavior. I noticed some things that weren't going through, some traffic that wasn't going through in the right way. But I'll be completely honest. Had I not had and been capable of using a protocol analyzer, I would not have seen it. I would not have noticed it. Okay, things had been flaky. I'd noticed things had been flaky for a couple of weeks, but I had no idea why. Okay. And I finally found it, and I've reloaded the firmware on my device, and I've upgraded my firewall software, and hopefully that'll stop it, but who knows, right? I don't know. And I'm a little unusual in that I run a firewall and my regular, Netgear router. But most people don't do that. But my firewall software didn't catch this either. It sailed right through. Keep in mind that vulnerability that I showed you is HTTP from the inside. Okay, nothing will catch that. Nothing will stop that. So it's pretty rugged. Any other questions?
If the device gets infected, and let's say someone just replaces the device, the infection remains on the old device you've replaced.
That is certainly a possibility. Yes.
So even if it's resold
if nobody
and powered
reflashes
up,
they power it up in a new place, that infection spreads to there. And one of the things that we're seeing here is that these things, some of these infections are getting quite clever. They're showing characteristics not just of taking over the device and being able to use it for a distributed denial of service attack. The reason botnets are dangerous is they take over the device, they basically zombify it. It will normally, if they've written their code correctly, not like they did at the Deutsche Telekom deal, it will take over the device, it will continue to perform its normal function, but it will also be enslaved to the botnet to run whatever commands the botnet tells it to. They periodically check with the botnet to say, hey, you got anything for me to do? Okay, this is one of the ways that you can catch them. You can look for that traffic where it says it's going to go to a botnet controller that it's going to find in various different ways. The early botnets, those were a fixed IP address. That's relatively easy to defend against. The newer botnets are getting sneakier. They're finding more and more cryptic and roundabout ways to be able to connect themselves to their controllers to find out what they should be doing. And because of that, a lot of times that what they're doing may be not just to attack something, but to infect something else. And so once you have an infected IoT device, it can be used as a springboard or launch pad to compromise your PCs, to compromise your TV box, to compromise other things that are on your network. It's particularly bad in the home environment because we have no professional IT and no skill set to deal with this stuff. As I said, it's difficult to find this stuff even if you know what you're doing sometimes. Okay, if you've got a fairly, the infection on my router was subtle enough that I noticed some weird behavior, but that's because I play with this stuff. Okay, most people don't. 999 people out of 1,000 would have no prayer of ever finding what I found.